Hello everyone, in this video I'm going to discuss the general power rule for integrals. So if you have u equals to fx and then we have integral of u raised to power n du is equal to, so it's basically the same rule. So you increase the power by 1 and divide by the new power plus c, and n should not be equals to -1. Or you have an alternative form that you can write for the same formula. So if I plug in u equals to fx, so my formula becomes, so if you have fx raised to power n and then d of fx, so the integral is equals to u raised to power n plus 1 over n plus 1 plus c, and n should not be equal to -1. Alright, so what is this dfx? So dfx is differential of fx. So in other words, we can write the same formula as, so fx raised to power n. So dfx means derivative of fx times dx. So this is together your dfx, and that is equal to fx. So increase the power of the function by 1, divide by the new power plus c. So let's do a few examples in which we can use this formula. So this formula is basically, what we are doing here is we are reversing the chain rule. So you can think of this as chain rule in reverse. Remember, in the derivative, when we have another variable as opposed to x, so we used to apply chain rule. So similarly, in case of integrals, so you can think of this as chain rule in reverse. So let's see how it works. So first you have integral of x raised to power 5 plus 7 whole thing raised to power 9 times 5x raised to power 4 dx. So first I will tell you the traditional method, which is our U-substitution method, and then I'll show you the quick way to do the same problem. So let's put this more complicated function as u. So I tried to do this substitution here. So my integral is going to become integral of u raised to power 9, but still I have this 5x raised to power 4 dx. So when we do the substitution, we need to get rid of the original variable, and everything should convert into new variable. So in order to find the value of dx, so we need still the value of dx and 5x raised to power 4. So let's take the derivative on both sides. So we get du over dx. So that is 5x raised to power 4 plus 0. So from here, du is equal to 5x raised to power 4 dx. And now we can clearly see that in place of 5x 4 dx, we can write du. So the original integral is replaced into a new integral. So everything is terms of new variable. So this matches our general power rule. So the general power rule is, so we increase the power of u by 1, divide by the new power plus c. So our answer is u raised to power 10 over 10 plus c. But since our original problem was in terms of x, so let's plug in the value of u back here. So substituting the value of u, so we get x raised to power 5 plus 7 raised to power 10 over 10 plus c. So if we analyze, so what steps we did for this problem. So steps for u substitution were, so now I will show you the quick way of doing this problem. So you can think of this problem as, so if we think of x raised to power 5 plus 7 as our fx, so we have fx raised to power 9, and then we have the derivative of this function outside. So derivative of x raised to power 5 is 5x4 plus 7 is just 0, so 5x4, and then we have dx. So this is our form which we discussed here. So if you have something like a function raised to power n and the derivative of function, differential of function with it, so then we can raise the power of function by 1, divide by the new power plus c. So overall, we can just write this answer in one step. So it should be So fx raised to power 10, so which means x plus 5 plus 7, x raised to power 5 plus 7 raised to power 10 over 10 plus c. So you can choose which method you like better. So basically this one is, so you have a function raised to power n and you have the differential of the function. So if you have this form, so you can simply do the function raised to 1 power more divided by the new power. Again, let's do one more example. So let's first do step by step with all the steps. So we have integral of 4x squared minus 10 raised to power 8 x dx. So I can quickly see that. So we have x squared inside. So if I take the derivative, I'll get a single power of x. So I can use the substitution. So let u equals to 4x squared minus 10. So it means we also need to find du. So du over dx is 8x. From here du is 8x dx. Our problem becomes, so let's substitute the values. So u raised to power 8, and in place of, okay, so from here we need to have the value of x dx. So x dx is, du over 8. So let's just write that. So du over 8. So let's do this integral. So 1 over 8 integral of u8 du. So by using the power rule, because these are the same variables, right? So we can use the power rule. So 1 over 8 u raised to power 9 over 9 plus c. So overall we get 1 over 72, and we can plug back the value of u. So in terms of original variable, we get 4x squared minus 10 whole thing raised to power 9 plus c. So this is our integral. So that's our first method. So if you want to consider the second method, so I'm just going to remind you what form I'm going to make. So we have fx raised to power n f prime x dx. So that is equal to, so you increase the power of the function by 1, divide by the new power plus c. So in this case, if I consider fx raised to power 8, and then in order to make the differential of this, so what would be the derivative of 4x squared minus 10? So that would be 8x. It means we need another 8 here to make f prime x. So that will make my f prime x dx. But also, since I added an 8, so in order to neutralize the effect, so I need to divide by 8. So it means our new function becomes of this form. So 1 over 8 integral of some function raised to power 8 and the differential of the function. So now it means our answer should be, so 1 over 8 as it is. So using this formula, so we have function raised to power 8. So it means we can increase the value of function by 1. So the power of function by 1. So 4x squared minus 10 raised to power 9 over 9 plus c. So overall we get 1 over 72 4x squared minus 10 raised to power 9 plus c. So this is the shortcut method. So if you can just make the form, so you can just write the answer in one step. Again, in next one, we notice that, so we have 2x cubed here, so we have x squared here. So we can make the derivative of the function here. So let u is equal to 2x cubed minus 1. So du over dx is 6x squared, or du is equal to 6x squared dx. And when we do the substitution, so we notice that we get integral of u raised to power 4, and in place of x squared dx we write du over 6. So x squared dx is du over 6. So we replace everything in terms of new variable. So we get integral of 1 over 6 u raised to power 4 du. So 1 over 6 u raised to power 5 over 5 plus c. And So 1 over 30. So u raised to power 5. So let's put the original variables back. So this is our answer. And alternatively, you could have done this just in one step. So we had something 2x cubed minus 1 raised to power 4 x squared dx. And if you think about the derivative of 2x cubed minus 1, so that would be 6x squared. So in order to make the derivative, so you add a 6 and you multiply by a 6 and you divide by a 6. So now you got something of the form a function raised to power 4 and differential of the function. So this is your function and this is your differential of the function. So our overall answer would be, so function raised to power 1 power more. So that is 5 over 5 plus c. So it was negative here. So whatever method works for you, just go for that. Let's try another example. So again, in this one, we notice that we are given this integral. So I'm just going to write in the power form first. So inside the bracket, we have t squared minus 1. So that's what we should substitute. So let u is equal to t squared minus 1. So du over dt would be, so here the variable is t. So that should be 2t. From here, du is equal to 2t dt. But since when we're going to do the substitution, we need the value of dt. So dt is equal to du over 2t. So let's do the substitution and try to replace everything in terms of u. So 3t, so we don't know the value of t yet, so let's just write as it is. And t squared minus 1 raised to power half, so that becomes u raised to power half, and dt becomes du over 2t. So now we notice that our t is gone. Or we could have simply figured out the value of t dt, which is du over 2. Alright, so in the next step, what we are left with, so 3 over 2 integral of u raised to power half du. And now we're going to use our power formula. So using the power formula, so increase the power by 1, divide by new power plus c. So we notice that 3 over 2 and 3 over 2 cancel each other. And we are left with u raised to power 3 over 2 plus c. And last step is plug back the original variables. So t squared minus 1 raised to power 3 over 2 plus c. So this is our integral of given function. So integral of 3t square root of t squared minus 1 dt. So this is our U-substitution method. So alternatively, if you want to do it in a shortcut method, so you can notice that here we have a function which has square term. So ft raised to power half. And also we have, so if you take the differential, that's going to be 2t. So we can make it 2t here. So we can remove this 3. So 3 you can bring outside. And you can multiply by a 2 and divide by a 2. So now you have this form. So function raised to power half. And you have the differential of the function along with it. So this integral is easier to solve. So our answer would be 3 over 2. So increase the power of the function by 1. So that would be t squared minus 1 raised to power of half plus 1, so which is 3 over 2. So 3 over 2 plus c. So 3 over 2 and 3 over 2 cancels. We are left with t squared minus 1 raised to power 3 over 2 plus c. I hope that makes sense. So the gist of this video is that if you see a function raised to some power and its differential along with it, so then the integral is simply function raised to power n plus 1 over n plus 1 plus c. If you like this video, please hit the subscribe button and I'll see you next time. Thanks for watching.